this video, I'm just going to go over the answers to the past paper questions 6 to 8 in your quantitative booklet. So first of all, question 6, and this question was about the amount of magnesium chloride that can be produced from a given mass of magnesium carbonate. Again, if we look at the equation as usual and see the ratios, we'll see that there 1 magnesium carbonate reacts with 2 hydrochloric acid, produces 1 magnesium chloride, 1 carbon dioxide and 1 water. And as we'll see in this calculation, it's that 1-to-1 ratio there, that 1 magnesium carbonate produces 1 magnesium chloride is an important one. So the usual thing at the start, some RFMs, so MgCO3, and most of you can do this very well. So 24 for magnesium, 12 for carbon, 16 times 3, so a total of 84. In the same way, MgCl2, 24 plus 35.5 for chlorine times 2, 95. Then the number of moles of magnesium carbonate. Now we'd worked out here that 1 mole was 84. So use that little equation, N equals M over RFM. So the RFM is 84. So 4.2 divided by 84, and that gives us 0.05 mole. Then we had to use that answer, 0.05 mole, calculate the maximum mass of magnesium chloride that can be produced from 4.2 grams of magnesium carbonate. Now, our ratio, as we said, from this to this is 1-to-1. So for every 1 mole of this, we make 1 mole of that. Now, what that means is 0.05 mole of this, of magnesium carbonate, produces 0.05 mole of magnesium chloride. That's the 1-to-1 ratio. So to get the mass of that, 1 mole of magnesium chloride, we'd worked out up there in part 2, I think it was, is 95. So 1 mole of MgCl2 is 95. So 0.05 mole, we'll multiply the number of moles by RFM, 0.05 times 95, 4.75 grams. And then the percentage yield, now getting the numbers right, most of you did the calculation correctly in the sense that you got the actual yield over theoretical yield. Now, which is which? Well, this is the actual yield. When the reaction was carried out, you actually got 4.2 grams. So that's the bit that goes on top. And the theoretical yield was your answer here. And again, lots of you maybe made a couple of mistakes further up and end up with the wrong answer here, but then carried that one down correctly. And in a GCSE exam, you'd still get the marks for that. So we had got 4.75, so we put that down. So 4.2 over 4.75 times 100, and that works out 88.4%. Question 7, 2 RFMs to start off with. So NH3, 14 plus 1 times 3, 17. H2SO4, 1 times 2 plus 32 plus 16 times 4, 98. And then NH4 2SO4. Now, check out what's in the brackets first. N and H4, so 1 nitrogen and 4 hydrogens. So nitrogen is 14, 4 hydrogens would be 4, so 14 and 4 is 18. So what's inside the bracket is 18, and then we're multiplying that by 2. So 18 times 2, so that'll give you what was in the bracket, 1 sulfur, 32, 16 times 4, and that totals up at 132. Then to get our answer here, we had to use the RFM, calculate the number of moles of ammonia in 4.25 grams. So N equals M over RFM, so 4.25. And then back on the previous slide there, we'd worked out that ammonia was 17. So 4.25 over 17, 0.25 mole. Now, this bit here, it said, using the equation given at the start, and you'll see I've copied it down here again, so there's the equation. Calculate how many moles of ammonium sulfate, this one, is formed from 4.25 grams of ammonia, this one. Now, 4.25 grams we'd worked out up here was 0.25 mole. So let's look at the ratio. Well, the ratio is for every 2 moles of this, you need 1 of this, and you produce 1 of this. So the key ratio then is that one. So every 2 of those, you make 1 of those. So the ratio is 2-to-1. So that means if we've 0.25 mole of ammonia, for every 2 of those, we only make 1 of these. So you divide this by 2, 0.25 over 2, 0.125 mole of ammonium sulfate. And then to turn that into the mass, we know that 1 mole of ammonium sulfate was 132, we'd work that one out. So multiply that number of moles, 0.125 by 132, and that should be 16.5 grams. The calculation underneath it, there's a little typo, so don't worry too much if you got the right figures and things. You got the wrong figures because of that typo there. It should have been 14.5. Whenever you make 16.5, you'd get less than that, or that 16.5 or less than that. So percentage yield should have been 14.5. Now, some of you put 24.5 in. That was fine. I just ticked it and gave you a mark for it there. So 14.5, and then divided by this, the theoretical yield, multiplied by 100, 87.9%. And then two reasons why it would be less than 100%. So you get loss of transfer. Do you remember if you're going from one container to another? The other thing is those side reactions. Ammonia, we're working out theoretically it should have been converted into this ammonium sulfate, but it could be converted into something different. This was called a side reaction, do you remember? So ammonia could be converted into something different than ammonium sulfate. And then that other one was called equilibrium. The reaction is reversible, so it doesn't go to completion because it's reversible. So any two of those three gives you the mark for those. Okay, and the last question, so again, a couple of RFMs. The equation, we're going to be looking at is that sodium hydrogen carbonate, NaHCO3, so the sodium hydrogen carbonate going into sodium carbonate, water, and carbon dioxide. The ratios, for every 2 molecules or every 2 moles of those, we'll get one of these, one of these, and one of these. So a 2 to 1 to 1 to 1 ratio. So, a couple of RFMs first of all. NaHCO3, 84. Na2CO3, 23 times 2 plus 12 plus 16 times 3, 106. The number of moles in 4.2 grams of the compound, well, again, we use that N equals M over RFM. 4.2 over, and it's the sodium hydrogen carbonate, so it's this one, 84. So 4.2 over 84, 0.05 mole. And then how many moles would we get? Well, again, look at our ratio. It's 2 to 1. For every 2 of those, we make one of those. So we'd worked out 0.05 mole of NaHCO3. So divide that by 2, and that'll give us 0.025 mole, because for every 2 of those, you only make one of these. So 0.05 mole produces half that amount, 0.025. And then the mass of it, well, 1 mole of sodium carbonate should be 106. So therefore, M equals N times RFM. So 0.025 times 106, 2.65 grams. And then when the reaction was carried out, 1.8. So we've actually got 1.8. Up here we'd worked out theoretically we should have gotten 2.65 grams. So percentage yield actual mass 1.8 over theoretically 2.65 times 100, 67.9%.